So we're going to find the derivative of 1 over x squared using the limit definition of the derivative. So the first thing you should write is f prime of x equals the limit as h goes to 0 of our difference quotient. Now we're going to input our function to see what that looks like. Now f of x plus h means we're putting in x plus h any place there's an x. So that will look like 1 over x plus h, the quantity squared. F of x is just our original function, and this is all over h. Now one thing that might make this a little easier to deal with is we may go ahead and just, instead of dividing by h, we'll think of it as multiplying by 1 over h, so we don't have the fraction in the fraction. And here we're going to need a common denominator. So I'm going to multiply this guy by, that should be squared, by x squared over x squared, and this guy by x plus h squared over x plus h squared to give me a least common denominator of x squared times x plus h, the quantity squared. And my numerator is going to be x squared minus x plus h, the quantity squared. This is over my common denominator of x squared times x plus h, the quantity squared. So what's going on to get from this step to this step is, instead of dividing by h, we wrote this as 1 over h, so this h is right here. And then we found a common denominator so we can subtract the fractions. It's important to keep those parentheses because this negative will have to distribute. We do need to write limit as h goes to 0 until we've taken that limit. We can't take it right now, we'll just end up with 0 over 0 or an indeterminate form. On top we have x squared minus, now this needs to be FOILed out, and it FOILs out to x squared plus 2xh plus h squared all over x squared times x plus h, the quantity squared. I'm not worried about multiplying out the denominator because I know eventually I'm going to be taking the limit as h goes to 0. That'll eventually become 0. This thing will simplify fairly easily at that point. Next step, I have to distribute this negative sign to all these terms. So I have the limit as h approaches 0 of 1 over h times x squared minus x squared minus 2xh minus h squared all over x squared times x plus h, the quantity squared. These we see cancel right away. And what we get left with is the limit as h approaches 0 of 1 over h. Notice the two terms both have an h left in them, so that numerator I'm going to rewrite as h times negative 2x minus h, and that's just factoring that h out, over x squared times x plus h, the quantity squared. Let's make that a little nicer so that's an x squared there. Now, this h will cancel out with this h. I can now take the limit as h goes to 0, which means I'm going to have on top negative 2x minus 0, and in the denominator, x squared times x plus 0. Notice I'm no longer writing that limit as h goes to 0. Our last step, let's clean this up a little bit. We end up with negative 2, that should be the quantity squared, that square right there, minus 2x over x squared times x squared, which is x to the 4th, which we can actually simplify one of the x's here with this one, and we get a derivative of minus 2 over x cubed. So there's what we're getting for a derivative from the definition of the derivative. Well, if we were to use our power rule, this would be x to the minus 2, in which case f prime of x would be negative 2x to the minus 3, or negative 2 over x cubed, verifying what we got from the limit definition. So you should be able to figure out what the final answer is going to be, and then it's just doing the algebra to prove it.